Hello friends, Namaste and Jai Hind. Welcome to my show Technology and Engineering Made Simple. In the last lecture, we saw the concept of exponential function. We also saw the concept of complex exponential function and its relationship with the sine wave function, which forms the basis function in the formation of various signals. In this lecture, we are going to see the concept of vector. Vector is an abstract concept in mathematics, and it is defined as a physical quantity which has both magnitude and direction. It is also defined as a set of numbers. So before we dive into evolution of vector, we'll see the concept of coordinate system and then evolution of vector. So this is a fundamental definition, a set of numbers, how it is generated. So we consider first a one-dimension space which has only x-axis. Now we define a point px which is at some distance from 0 and can be called as a distance x. Now it has only a magnitude which is a distance x and no direction. So it doesn't form a vector quantity. But when you see the point in two-dimension space, it needs two coordinates, x and y. Now when you join this point with origin, it can be also represented as a radius r and angle theta with respect to x-axis, and hence it forms a vector quantity because it has a magnitude r and the direction theta with respect to x-axis. Now same concept can be extended to three-dimension space which needs three coordinates, x, y, z. And the same concept is extended here by joining a point with origin, which will give the distance r and angle theta with respect to x and z plane. Now, this concept, if it is generalized to n-dimension space, then one can imagine that there are n coordinates which are represented in this graph as E1, E2, E3, up to En. Now, practically, it is not possible to graphically show more than three dimensions because human cannot imagine multi-dimension space that is more than three-dimension space due to limitations of our brain and visual system. However, mathematically, one can imagine n-dimension or n-dimension coordinate system having coordinates where if you pick up any two coordinates, they will be orthogonal to each other. That is, the angle between any two coordinates is 90 degrees. And the same concept one can see in xy plane, xyz plane, which is a three-dimension plane, and can be extended in n-dimension space. So in n-dimension space, if you pick up EM and EN, any two dimensions, they will be orthogonal to each other. And that is a way mathematics can help to visualize n-dimension or infinite dimension space. Now here, a point is represented with n coordinates, which are called x1, x2, xn. So x1 is a distance from origin on E1 axis, x2 is distance from origin on E2 axis, and so on. So here, the concept of radius and angle can be extended similar to two-dimension and three-dimension space. So if you join point with origin, it will give the radius r and angle with a plane that will form the direction. So imagination of radius and angle in n-dimension space will be slightly difficult. So one can simplify it by representing as a column of numbers which are nothing but x1, x2, xn. These are the magnitudes of point from each axis, and it is represented as a vector. How one can apply this concept in real life application? So here, the simple application of generating vector, it is a sampling of analog signal with the help of train of impulses, which we saw in our first lecture. Now here, if you see graphically, you are having, say, audio signal which is passed through a analog to digital converter which sample signal at a uniform interval called sampling interval TS, and then it will generate a vector of n samples. So that is, one can visualize it is a point in n dimension space. The same concept can be extended to image signal as well. However, here small difficulty is image is a two-dimensional signal which has got x and y dimension. Therefore, how one can convert this two-dimension signal into a one-dimension vector? So simple process is called generating a lexicographic sequence in which one column is stacked below another column, and therefore one can convert a 2D signal into a 1D vector. For example, image has dimension say 32 by 32. So there are 1024 pixels in the image. So these are the discrete sample values generated from analog image. Now this one dimension vector generated through lexicographic sequence will form 1024 dimension point in 1024 dimension space. So image can be visualized as a vector with n dimension space. Now same concept can be applied to any sensor system. For example, video signal, which is a 3-dimension space in which the images are generated at regular time interval, typically 30 frames per second. So similarly, we can generate a 1D signal from a video signal using lexicographic sequence. And same concept can be extended to radar signal, LiDAR signal, X-rays, MRI, which are used in signal processing as well as in machine learning applications. Now the next question is, here we are having a vector of variables x1, x2, x3, xn, which are nothing but a sampled version of 1D, 2D, 3D signal in real life application. This concept can be extended to the vector of functions as well. So we saw exponential complex function, which forms a sine wave function. So here in this case, we are showing a vector of e raised to j x1t, e raised to j x2t. So we are having n sine waves in a column vector up to e raised to j xn e. Same concept can be extended to the operators as well. So this operator plays an important role in the analysis of n dimension signal defined as dabba by dabba x1, dabba by dabba x2, dabba by dabba x3, or it can be a derivative with respect to function as well. So here in today's lecture, we saw how the vectors are represented as a set of numbers, set of functions, or set of operators. In real life application, there are vector mathematics as well. So a typical operation is called a dot product operation, which is used in implementation of many signal processing operations like FIR filters, IR filters, various transform, Fourier transform, Laplace transform, Z transform, and it also forms a basis for generating matrices. So in our next lecture, we'll see what is a dot product as an important mathematical model in implementation of various applications. I hope you enjoyed this show. Thank you for watching this show.